Hello everyone, and welcome back to the R from Scratch. So today we are going to continue our journey of learning R programming from absolute zero, especially for bioinformatics, data science, and research students. So in the last video, we learned how to import our raw data like CSV files, Excel files into R using R Studio. That was a really important step, but now that the data is inside R, we need to understand what kind of objects we are actually working with. Today in this video, we are going to explore the core data structures in R vectors, factors, lists, matrices, data frames, and tables. I know it sounds a little technical, but understanding these will save you from so many headaches later on, especially when we're dealing with real patient data, treatment groups, or gene expression data sets. So let's get started. So let's create our example dataset. The best way to learn is by doing. So I'm going to create a simple dataset that looks exactly like something you might import from a CSV file in a real bioinformatics project. So I will call it patient data. It has patient ID, age, treatment groups, biomarker level, and response by the patient for each patient. So this is very similar to clinical or biomarker data you will work with. So I will be typing this following code to create the patient data frame, and like it will have patient IDs 1 to 15. It will have age for each corresponding patient along with the treatment group, biomarker level, and response factor. So to save it in memory, I will press Control Enter. So it will, like here in console, you can see it give me. Now let's print it to see what we have. So to print it, we will write print in bracket patient underscore data, the name of our data frame that we declared earlier. So I will again Control Enter. Then here you can see in the console that we have 15 patients with different ages, treatment groups, biomarker levels, and whether they responded or not. So the simplest data structure in R is a vector. A vector is just a sequence of values of the same types, like all numbers or all characters. So let's extract just the age column as a vector. To extract just the age column from patient data, we will again create a new vector of data like a variable ages, which we will be extracting from patient data. And the column name that we are extracting is age. So this column, the name here after a dollar sign. So the name of data frame, dollar, and the name of the column. So we will be declaring this age. Now I want to print to see what values does my age vector contains. So I will click on Control Enter. Now here you can see in the console, it prints the age in a vector format. If I want to check the class of this particular vector, I can write class in bracket, the name of the vector. So it's numeric. So it says numeric. That's a vector. Vectors are the building blocks of almost everything in R. Now let's move to the factors, the most important for bioinformatics. So factors are special vectors used for categorical data. So in bioinformatics and clinical research, this is extremely important. Look at our treatment group column. It's already a factor. So look at our treatment group column. It's already a factor. Let's check its labels. So to check its labels, let's first check the treatment group data as a single column. So I will press print. I will write print in bracket the patient data and again the dollar sign and the name of the column that I want to see in my like output. So to check the labels, I will write labels underscore not labels in bracket patient data and again the same the name of the column. As you can see labels, we have three labels: control, drug A, and drug B. It knows the categories which are control, drug A, and drug B. So this becomes super useful when we do statistical test or create plots later. So R will treat them as categories, not just random text. So always convert your category variables like treatment group, gender, or response status into factors. It will save you a lot of trouble downstream. You can also see the amount, like the number in each particular category. So the next is, so now let's talk about the data frames. So this is probably the most common structure or data structure you will use. So a data frame is like an Excel spreadsheet inside R. It can hold different types of data in different columns. So, but there is something even better called a table. So Tibbles are modern data frames from the Tidyverse. They print nicer and have better behavior. So first, let's like I have already installed library Tidyverse. In my previous video, I have told you how to install a library. If you do not know, you can visit like previous video in the playlist. So I have installed. I will just import it. So here you can see I imported my library. Now I will be creating a patient table. So to create a table, I will like declare a name of table, patient underscore table, and will give the sign and write s table, the name of data frame which I want to use as a table. So I will click enter. So it will like in command line you can see it there is no error. It means it's successfully generated. Now I will click on print table so that it will show me the particular table as a data frame or a spreadsheet like structure in command in my console. So let's click it here. So you can see here 1 to 15, the patient ID, age, treatment group, biomarker level, and response, and the data types below the just below the name of the columns. So notice how much cleaner the output looks. So tables are what we will mostly use going forward in the series. Now coming to the uh, lists. So lists are the most flexible structure in R. A list can hold anything, vectors, data frames, even other lists. So like nested lists. So to create a list, my list, I will create a list like patients. I will include, as I said, it can hold anything. So I will include a data frame patients data, a summary state, which will create the summary like from a numerical column, and groups where it will count the levels like the number of categories in each. So let me declare this my list and I will click enter. So there is no error. It means my list has been created. Now to see what inside the list, I will click on. I'll not. I will click. I will just press Control Enter, and you can see this is what my list contains: patients, data frame, summary states, and groups. Okay. Now let's talk about matrices. So matrices are two-dimensional structures that can only hold one type of data, usually numbers, useful for certain calculations, especially in genomics. Let's quickly create a matrix from our numeric columns. So to create a biomarker matrix, as matrix patient data, so we had two numeric columns. One is age and other is biomarker level. So to create a matrix, I will name the variable of the matrix. And I will write as matrix from the particular data set or data frame, the name of the columns like age and biomarker levels. Okay. So I will declare it. I will click Control Enter, and here it is created. The matrix is created. To see the matrix, I will run the print biomarker matrix. So now to summarize what we not to summarize that like we can see the matrix has been generated. You can see it here. So perfect. So to summarize what we learned today, so vectors are a simple sequence of same type. Factors are categorical data, like very important in research. Data frames and tables, your main working horses for tabular data. Lists, flexible containers for anything. Matrices that mainly contain numeric grids. So that's it for today. That's it for today's video on data structures. I hope this gave you solid foundation or a basic understanding what different type of data sets or data structures we will be using. So understanding these concepts early will make the rest of our R journey much smoother. So if this video helped you, please give it a thumbs up, subscribe to the channel, and hit the bell icon so you don't miss the next video. In the next video, we are going to start data wrangling using Deployer and the Tidyverse. So that's where the real fun and analytics work begins. You can download the complete script from the GitHub link in the description. The file will be uploaded as the same as the title of the video. So drop a comment below and tell me which data structure do you find most confusing or what topic do you want to learn next. Thank you so much for watching and I will see you in the next video. Keep coding, keep learning and happy learning.